We are discussing previous year's questions of CBSE Standard 12 Physics. Standard 12 Physics. Now we are discussing questions that are asked from electromagnetic waves. Okay, let's resume. How are the electromagnetic waves produced? By oscillating charges. Draw the sketch of linearly polarized electromagnetic waves propagating in the z direction. Indicate the direction of oscillating electric and magnetic field. Because these are 3 marks questions. So let's see. Oscillating charges produces oscillating electric and magnetic fields. This we know. These oscillating electric and magnetic fields with respect to space and time produce electromagnetic waves. Okay. Now linearly polarized light, this is the magnetic vector, this is along x-axis, this is the electric vector, this is along y-axis, this is induction vector, this is electric vector. Okay, and the mode of propagation k is perpendicular both the plane which contains the electric and magnetic vector, that is along the z direction. Okay, so this is how the diagram. Okay, that's all. This question is not from electromagnetic wave anyway. So this is Maxwell's generalization of Ampere circuitry law, so that in the process of charging of capacitor, the current produced within the plates of the capacitor is I equal to epsilon 0 d phi e by dt, rate of change of flux. Okay. Now, so modified Ampere's law by Maxwell. Maxwell actually modified the Ampere circuitry law. In Ampere circuitry law, mathematically, it was not possible to explain current continuity and hence inconsistency observed in Ampere circuitry law. Okay. Maxwell introduced the concept of displacement current. So what is displacement current? How it is arises? So displacement current arises due to the change in electric flux with time. So what is displacement current? It is epsilon 0 d phi e by dt. Now we know that from the definition that flux is equal to the product of E and A, intensity and area. So this is what is epsilon 0 A by, so sigma A by epsilon 0, this is the flux. So sigma is the charge density. So therefore QA by A epsilon 0 is equal to Q by epsilon 0. This is from the definition of Gauss's theorem. Charge enclosed by epsilon 0 is the flux. Okay, and sigma is what? Total charge density, charge per unit area, Q by A. So if you put the value of sigma as Q by A, so this is equal to how much? Q sigma A is the total charge by epsilon 0. This is the definition of flux. So sigma is replaced by Q by A, here Q by A. So A is already there. So now what is this? So d phi E by dt is equal to 1 by epsilon 0 from this equation. If we equate it, so we find that d phi E by dt equal to 1 by epsilon 0 dq by dt. Rate of change of current is rate of change of epsilon, okay, rate of change of charge. Okay, so therefore epsilon 0 into d phi E by dt is dq by dt. Okay, this is the current, rate of change of charge is current. So this is conduction current, which is same as epsilon 0 d phi E by dt. Hence from equation 1 and equation 5, this is equation 1, this is equation 5, displacement current is equal to IC. So thus the generalized Ampere circuitry law can be written as mu 0 is equal to IC plus IT. Okay, mu 0 into this. This is the line integral of B dot dl. So therefore the conduction current IC is because of the charge flows, but the displacement current is because of the electric flux. So one more term is added. This is from electromagnetic wave. Name the parts of electromagnetic spectrum which is suitable for radar system in aircraft. Okay, used in the treatment of muscular strain, used as a diagnostic tool in medicine. How these waves can be produced. So microwave is suitable for aircraft navigation radar. It can be produced by klystron, magnetron and gun diode. Infrared radiation is used for muscular strain. It can be produced by hot bodies, vibrations of atoms and molecules. X-ray is used for as a diagnostic tool. It can be produced by bombarding high energy electrons in metal target, X-ray tube and inner cell electrons. Okay. Name the next question. Name the electromagnetic waves which are suitable for radar systems used in aircraft. Okay. Write the range of frequency of these waves. If Earth did not have atmosphere, what its average surface temperature be higher? Would its average surface temperature be higher or lower than what is now? Okay. In absence of atmosphere. Okay. Now the third part is electromagnetic waves exerts pressure on the surface on which it is incident. You have to justify. So microwave frequency is in this range 10 to the power 10 to 10 to the power 12 hertz. If there is no atmosphere, then greenhouse effect will be absent, because of the greenhouse this waves gets reflected back. So hence the temperature will be lower because no more reflection coming back to Earth. Now since energy and momentum associated with electromagnetic wave, hence an electromagnetic wave exerts pressure and on the surface upon incident. Okay, because it has momentum, it has energy. Next question. Which of the following waves can be polarized? Heat waves, sound waves? Say. Give the reason. Heat waves are electromagnetic waves like light waves. Okay, exhibits polarization since electric vector oscillates perpendicular to the direction of propagation in all directions. Sound waves are elastic waves. Okay, they cannot be polarized. There is and sound they cannot be polarized. Okay, the direction of oscillation is along the direction of propagation. Now, why photoelectric effect cannot be explained on the basis of wave nature of light? Write the basic feature of photon picture of electromagnetic radiation on which the Einstein photoelectric equation based. So photon is quantum mechanical particle. It has non-zero. Normal particles having non-zero rest mass. When it is at rest, there is a mass involved. But photon has zero rest mass. When it comes to rest, the mass is zero. So as per the nature of light, intensity is the measure of energy carried by light. Therefore, higher intensity light falling on metal surface should impart higher energy to electrons and electrons get ejected. Okay, having higher kinetic energy. However, the photoelectric effect, we know that the kinetic energy emitted in the electron is independent of intensity of light. It depends on the threshold frequency, that is phi 0. So if it satisfies the frequency, then only the photoelectric electron gets emitted from the metal plate. If you incident more energetic ray, then it is not necessary that electron gets emitted. Okay, so this cannot be explained by normal theory, correct? By dual nature of light, by wave theory. So we know if the frequency of incident light is less than a minimum required frequency called the threshold frequency, electron will not emit. This threshold frequency cannot be explained by wave nature of light. Now, third part, there is absolutely no time gap between the incident of energy and emission of electrons. Electrons emit spontaneously as soon as the light gets incident on the surface. However, in classical wave theory, we know that the imparting energy to electrons and distribution of energy to atomic electrons should take some time. Okay, so why there is no time gap between incident of light and emission of electrons? This cannot be explained by normal theory. Thus, instantaneous energy emission in a photoelectric effect cannot be explained by wave nature of light. Okay. Basic feature of photon. So, light energy carrier that is the photon particles, are not ordinary particles, they are quantum mechanical particles, okay, called photons. Ordinary particle have non-zero rest mass. When velocity is zero, then its mass is not zero, okay, for ordinary particle. But photon, when velocity is zero, then mass is zero for photon, correct? This is for photon. So now mass equal to relativistic mass given by the Einstein theory of relativity. M is equal to, M is mass when velocity is v, m0 is the mass of the particle when it is at rest, when velocity is 0, 1 minus v square by c square. Now see, in this equation, as the v increases, the denominator decreases, so this mass increases, correct? So v is 0, then rest mass should be 0, so m0 is the rest mass. So this is the mass is actually for quantum mechanical particle, relativistic motion is considered, means when it depends on the mass of a particle, depends on its velocity, okay? So this is how it is written. C is the velocity of electromagnetic wave in air, that is 10 to the power 8 meter per second, okay? This is the value of C. So each of energy of each photon is given by h into nu, where h is the Planck's constant and nu is the frequency of incidence, frequency of the wave. So, okay, and frequency into wavelength is velocity. So you can replace frequency, say frequency by c by lambda, okay? H is Planck's constant. Now, third, incident photon energy is used to eject electron, that is called work function. The minimum energy required to eject electron is called work function. Remaining is part converted as kinetic energy. This is given by Einstein equation, okay? So this is, suppose E is the energy incident, part of it is used for ejecting the electron. This is work function, plus the remaining part is with that energy the electron travels, and this is equal to half m into v square, where v is the velocity of this ejected electron. So electron emission depends on the frequency of incident light, not on the intensity of incident light. This is very important, okay? If frequency is higher, then electron emission will be higher. Now there is a minimum frequency of photon, which if it satisfies the threshold frequency, then only the electrons will get emitted from the surface. Okay. So this is basic features of photons. You can take the screenshot. I am removing all this. So today we have to finish the very small chapter, electromagnetic wave. Okay. Yes. What are the direction of electric and magnetic field vectors relative to each other and relative to the direction of propagation of electric magnetic wave? So this already explained, okay. Next question. A plane electromagnetic wave travels in vacuum in z direction. What can you say about the direction of electric and magnetic vectors? Same question. When monochromatic light, monochromatic means single wavelength, polychromatic means multiple wavelengths. When monochromatic light travels from one medium to another medium, its wavelength changes but the frequency remains same, okay? Because of, see, when refraction happens, what is not changing is the frequency, okay? Frequency is more fundamental. Now velocity is frequency into wavelength, velocity is frequency into wavelength, okay? Since the velocity changes while passing through the medium, either frequency must change or the wavelength must change. So nature requires that the phase of an electromagnetic wave must remain continuous across the boundary. This is called boundary condition. Later we said that this is boundary conditions, okay? So in order for this phase to be continuous, for all times the frequency must remain constant, okay? So what is not changing in case of refraction, when electromagnetic wave travels from one medium to other medium, it is the frequency which is more fundamental. This does not change, okay? Remember, wavelength changes. As the wavelength changes, velocity in this medium and velocity in this medium are different, okay? How are infrared waves produced? Why are these referred to as heat waves? Now, hot bodies and molecules, infrared waves are produced by hot bodies and molecules, lasers. in global as thermal light source, where silicon carbide rod, when electrically heated by 1000 to 1650 degrees Celsius, it emits infrared IR waves. Okay, so radiation from sun, there also we get this red waves. Since most of the thermal radiation emitted by objects near room temperature, so near room temperature are infrared, hence referred to as heat waves. Okay. Use in night vision devices like night vision camera, infrared illuminations are used to see people or animal secretly. Okay, next question. A alpha particle projected along x-axis. Alpha are double ionized helium atoms. Okay, it contains 2 unit charges. So alpha particle along x-axis experience a force due to the magnetic field along y-axis. What is the direction of magnetic field? Okay, so this is alpha particle. This suppose xyz. The alpha particle is moving along x-axis. Okay, it experiences a force along y-axis. Okay, so what is the direction of magnetic field? Now we know that the force experienced because of its velocity of charged particle is B cross B. B is the induction vector of the magnetic field. So the force must be perpendicular to B and V both. Now if V is along x-axis, force is along y-axis, then perpendicular to force is along y-axis, B is along x-axis, so it must be the velocity. So what is the direction of magnetic field? The velocity is along x-axis, so direction must be along z-axis. Okay, so this is satisfied. Then only the cross product of B and V will be this F, direction perpendicular to B and V. So particles projected along x-axis, that is velocity, force is along y-axis, therefore the magnetic field must be along z-axis. That's all. Next question. Name the part of the electromagnetic spectrum whose wavelength lies between 10 to the power minus 10 meter. Okay, in the range of 10 to the minus 10. It is the, okay. So we know that the wavelength range 0.01 to 10 nanometer. Okay, 1 nanometer is 10 to the power minus 9 meter, falls in the X-ray region. Okay. So what is the use? So airport security luggage scanner, we use it. When light waves travel from rarer to speed decreases, does decreases imply the decrease in energy carried by the light waves? Justify your answer. Okay. H into nu. Okay. So nu remains constant, H is Planck's constant, so energy does not change. Sketch the plane electromagnetic wave propagating along z-axis. This is theoretical question already explained. Name the FM waves used for studying crystal structure of solids. What is the frequency range? So X-rays are used for studying the crystal structures of solids. The frequency range is 10 to the power 16 Hz to 3 into 10 to the power 21 Hz. This you have to remember. The frequency of oscillation of electric field vector of a certain electromagnetic wave is 5 into 10 to the power 4 Hz. Okay. What is the frequency of oscillation of corresponding magnetic field vector, and to which part of the electromagnetic spectrum does it belong? The frequency of oscillation of magnetic field vector is this. So this frequency lies in the visible region. Okay, visual region of electromagnetic radiation. We have visible region. Okay, visual, ultraviolet, and infrared region. Okay, so this region lies to our visible region. Now, electromagnetic wave is traveling in a medium with a velocity this much. The electric field oscillations of the electromagnetic wave are along y-axis. Okay. Identify the direction in which the magnetic field's oscillations are taking place of the electromagnetic wave. How are the magnitude of the electric and magnetic fields in the electromagnetic waves related to each other? This already explained, but let's see. Since electric and magnetic fields are perpendicular to each other, therefore magnetic field oscillations are taking place along x-axis. Magnitude of the electric field and magnetic field in the electromagnetic spectrum are related by this. Okay, V0 is V0 by C. C is velocity of electromagnetic wave. Write any four characteristics of electromagnetic waves. Give two uses of radio waves and microwaves. So these are characteristics. Use of radio waves for television program transmission, for radio programs transmission. Okay, television uses higher frequencies than radio. And uses of microwaves for cooking purpose, we have microwave ovens. Okay, satellite television programs, mobile phones and radar systems. Now draw the level diagram of Hertz experiment set up to produce the electromagnetic waves. Okay, this is the level diagram. So Hertz experiment, describe it. Figure shows that the Hertz experimental setup is used for producing electromagnetic waves. Two large metal plates P and P dash. These are two large metal plates connected to the metal sphere S and S dash. Okay, this is the connected to the metal sphere S and S dash. The spheres are connected to an induction coil. Okay, this is the induction coil. By interrupting current in the coils, a sudden high voltage is set up across the gap. This voltage ionizes the air in the gap, okay, which produces oscillating current in the gap SS test. So this is the gap. Because of this high voltage, it produces oscillating current. This process results in the production of electromagnetic waves. These waves are detected by detector, which consists of a single loop of wire connected to the sphere GG test. Okay, this is the detector. So in our next class we will discuss about ray optics, optical instruments. Here we will discuss about microscope, means simple microscope and compound microscope, and we have telescope, we have astronomical telescope, terrestrial telescope, their magnification, resolving power, length, tube length, more associated with numericals, and then we have wave optics. Okay, so we'll resume this discussion in our next class. Thank you.